This is our video for Tuesday, May 5th for pre-cal, and our objective today is to talk about the sum of an arithmetic sequence. You need your books open to page 570. So in yesterday's video, we talked about what an arithmetic sequence is, and we talked about the explicit formula, and we had a little bit of a recursive formula. Today, we're going to talk about finding the sum of an arithmetic sequence. Tomorrow, we're going to talk about what a geometric sequence is. Thursday, we'll talk about what a geometric series is. All the homework is due by midnight on Thursday. And Friday, we'll have a quiz over sections 8.2 and 8.3. All right, so last week, we talked about sigma notation. And sigma notation is what you use to find the sum of a sequence. And so we were talking about arithmetic sequences yesterday, and arithmetic sequences where something is added to get the next term, that there's a common difference between the terms. And so last week we would just kind of write out the sequence and add them all together. If it's an arithmetic sequence, there's a quicker way. And on page 570 in the blue box, you see a formula for the sum of a finite arithmetic sequence. And we've talked before about finite means it has a stopping point. And it says the sum of a finite arithmetic sequence with n terms is given by s sub n equals n divided by 2 parentheses a sub 1 plus a sub n. All right, n is the number of terms. A sub 1 is the first term. And a sub n is the nth term. And so basically, if you want the sum of a finite arithmetic sequence, you take the first term and the last term, you add them together, and you multiply that by the number of terms divided by 2, and that will give you the sum of the terms. If you look on page 570 below the blue box, it says, be sure you see that this formula works only for arithmetic sequences. Using this formula reduces the amount of time it takes to find the sum of an arithmetic sequence, as you will see in the following example. So let's take a look at example 5. It says find each sum, and they have 1 plus 3 plus 5 plus 7, all the way to 19. We know it's arithmetic. We can see that they're adding 2. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 7 is 2. And you could just type all that in your calculator, but of course you know we're going to have ones bigger than this. So let's use the formula. Let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10 terms. So n is 10. Our first term is 1. Our 10th term is 19. And so we're going to add those together. I'm going to go ahead and 10 divided by 2 is 5, times 20 is 100. Again, you could just add all those together. But you know that we're going to have some that are a little more complicated than that. But you basically take the first term, the last term, add them together, multiply that by the number of terms divided by 2. Now, if you look at the top of page 571, it says the sum of the first n terms of an infinite sequence is called the nth partial sum. And the nth partial sum can be found by using the same formula. So this formula is for a finite that has a stopping point. If you have an infinite, well, of course you can't find the sum of the infinite number of terms, but if they say, hey, what is the sum of the first 100 terms of this infinite sequence, we can do that. So let's turn to page 574. And if we look at number 53, we have 8, 20, 32, 44, so forth and so on. And we have an n equals 10. Find the indicated nth partial sum of the arithmetic sequence. So they want the sum of 10 terms. And so we're going to have 10 divided by 2. Our first term is 8. What we don't have is we don't have our 10th term. Now, we could do the sequence. They're adding 12 each time, and we could do that all the way out to 10. Or we could use our formula from yesterday. And so we want the 10th term of our arithmetic sequence. And so we would take our first term, and we would add to that 10 minus 1 is 9, times the common difference is 12. And 9 times 12 is 108, plus 8 is 116. So our 10th term is 116. So I'm going to put that over here, 8 plus 116. And I'm going to add those together and multiply that by 5. And we're going to get 620. So of course they like this problem, or I like this problem, because it makes you use your formula from yesterday as well as your new formula for finding the sum or the partial sum of an arithmetic. Now again, this only works for arithmetic. All right, I want to look at one more. Let's look at number 63. It ties in with what we were doing last week. It says find the partial sum without using a graphing utility, and they want the sum of 100 terms, and the formula is 5n. All right, now I don't want to write this out 5 times, but I'm going to start, and I want to look, and I want to see if it's arithmetic, because if it's arithmetic, we can use our new formula. So when I put in 1, I get 5. When I put in 2, I get 10. When I put in 3, I get 15. 4 would be 20. So this, even though this doesn't look like our formula that we learned yesterday, we're basically just adding 5 each time. So this is arithmetic. So if I want the sum of 100 terms, I'm going to take 100 divided by 2. I'm going to take the first term, which is 5. Now I need the 100th term, so I would just put 100 in here, and 5 times 100 is 500. And so I'm going to put 500 here. And so I'm going to take 50 times 505 and get 25,250. So today, basically using our formula for the sum of, actually that's not the formula, n over 2 a sub 1 plus a sub n, the sum of a finite arithmetic sequence. Again, this only works on arithmetic. Today's work will be found on page 574. I want you to do the even 54 through 58, 64, 76, 79, and 82.